So I guess we're going to do part three because part two made me thinking about how much this stuff would actually cost if you measured how much energy you used in the Joule insulated versus non-insulated. So I got a little wattage meter energy detector off of Amazon for like $33 or something like that, which, thinking it would work or maybe it wouldn't work. But obviously it came in handy. So if you flash back to like part two and then part one, of course we get different ideas. But so this is part three, and so you can see that it insulated took right about an hour, just like it did the first go around, to heat to 175 degrees Fahrenheit, which in both cases, insulated and non-insulated, it was pretty close to the same. So even in the first experiment, which when I didn't have this electricity monitor, took about an hour to do both. For some reason it took a little longer this go around than it did the first go around, so that was kind of trippy. I'm not sure if it was different because it went through the electricity meter and maybe dropped some voltage. I'm not sure. But did the same from the 175 degree target point here and here. Went ahead and did the 24-hour test to see how many kilowatt hours it was going to pull. So given that the hour heated to 175 degrees in both experiments was about the same, the huge difference was from this point, 24 hours later, we get a huge gap between 2.49 kilowatts and 8.19 kilowatts. So I did a little mathematical deal there. So between these 2 points here, in 24 hours insulated, we only pulled 1.26 kilowatt hours. But in the non-insulated version, we pulled 6.93 kilowatt hours. So with my electricity after taxes and fees and all that nonsense, it's about 11.1 cents per kilowatt hour. And so in the insulated version, we get 13.9 cents in 24-hour period of time. And then in the non-insulated version, we get 76.9 cents per kilowatt hour. So percentage-wise, it's a 550% increase from one to the other. One would say, who the hell cares? If that's you, then I'm kind of with you. I don't think it's a huge deal. It's definitely not if you can afford the Joule and you can afford all the things that come along with Sous Vide, including the food. This isn't a big deal to you either. One thing I will say is that it was quite comforting not to have all of the heat in the kitchen. And if you were going to do a 36-hour or even a 60-hour, brisket or a 60-hour pulled pork, which I plan to do in the future, that might come in kind of handy, especially if I'm doing it in the summer and not in the wintertime. So not a huge deal. So I can say that this is not going to break the bank either way. But I wanted to show you, though, is this little gadget here, which is the electricity meter that I got off of Amazon for like $30 or so. So what it does, it comes with this nifty little extension, and it actually plugs into the back. Now you can plug this straight into the wall socket if you can, or if you don't want to, you can obviously kind of set it up outside if you need more room, like if you have a bunch of things plugged in. So I have that. And so real up close, you can kind of see, shows you your kilowatt hours, and then it shows you your minutes plugged in, and then your hertz, shows your voltage, shows your milliamps that it's drawing, also shows you the wattage. Now right now this device is on kind of sleep mode, so here in a minute it'll kick up. And then of course your frequency, I can't ever really figure that out, so maybe somebody's smarter than I am. Now we're back to kilowatt hours. So what we can do, though, if we ever wanted to change or delete something, We just push and hold the set button, and then we can hit OK to clear. So what I'm going to do here, let's go back to wattage because this is kind of fun. I'm actually gonna, this is my Breville tea maker. So it does hot water, it does boiling water, it does custom tea settings because it has a strainer basket that you put your tea in. You have a water and tea level, and then in the morning it sets in the morning to time and temperature. So at 5 a.m. if you want it to come on, so when you're 6 o'clock, you're ready to go and you want hot tea or you want tea made, then this will automatically come on. It will do its thing and it will set, ready, set, go. And if you want to keep it warm, you can activate this button. If you want the basket to actually just descend and stay in the water, it will do that on its own if you activate the basket button, which I always do. Once it comes to temperature, this will actually float up and down, kind of like if you were to actually seep tea with your hand in some type of seeping device or with a tea bag. So check this out. So we're at 0.60 watts. I'm gonna go ahead and turn my tea on, which you see it's at 55 degrees. And so I have mine at 195. My basket is obviously set. So remember it was at 0.6 watts. We're running 1500 or so watts through this bad boy, and then you can actually change this to kilowatt hours. It will read. So we're at a minute in, so if you ever wanted to be like, how long, so that way you can plug in. It does in minutes, not in hours. So if you run it for 1,000 minutes, you know, or so, then you got to divide that obviously and get that. But there's your hertz rating, which stays pretty same. My voltage dropped obviously. And then my amps. So it also does amps if you're figuring out what kind of amp draw you have and how many amps, if you can overload a circuit. So if you're going to run two things at the same time, which if I run this and the Joule at the same time off the same breaker, poof, it won't work. So live and learn, right? So we're back to our wattage, and then now we got 0.02 kilowatt hours. So this is kind of fun. You know, you just kind of play with that, and you can kind of see, you can kind of see the water start to do its thing, and then where I'm at. So if you want to turn it off, of course, you just click off. We're probably going to drop back down below our 1 watt rating. And it might stay above 1 watt since now that we have the indigo blue lighting and stuff like that on. So yeah, it's going to stay above that. But anyway, just a little thing. It's called a Pawnee electricity monitor. There's some reviews of this on Amazon. People don't like it because it didn't work after the first day. Let me just give you a word of caution. It does have an amperage rating and it does have a wattage rating. So if you have, you know, a 110 compressor, it's probably not going to work very long, or anything high amperage that's going to require high amperage for a long period of time. So, you know, the Joule at high capacity ran about 1,050 watts while it was heating. And then on the insulated version, it dropped to somewhere between 20 and 80 watts, pretty continuous during that 24-hour period of time, or the time that I did check it. On the non-insulated version, it was pretty consistent at about 350 to 400 watts of continuous power on the non-insulated version. So obviously that's why it pulls more juice in the non-insulated version. But anyway, hope you enjoy. Hope that kind of rings things up. But definitely get one of these if you want to see how your deep freezer, how much it costs to run, you know, how much it costs to run, let's say your refrigerator, will do that. And so it's kind of cool, kind of fun to do. But as for this, it was a cool experiment. Nobody will probably care. I probably won't either, unless I'm going to do long cooks. So yeah, man, thanks for watching. See you later.